All right, welcome back. Today's lesson we are going to talk about dilations. And a dilation is what happens when we enlarge or reduce a figure, if we make it bigger or smaller. And it's something that is similar to the original figure, which means it's proportional. And the corresponding lengths are proportional, but the angles are the same size, remember? So the center of the dilation is a fixed point. Usually we use the origin, and that helps keep the math easy to do and the figures easy to draw. So the ratio of the length of a size on the image, which is the one we produce, to the length of the original is called the scale factor. We're going to be using the proportionality to go ahead and find these scale factors. So let's go ahead and get started. This one says copy polygon ABCD shown on graph paper, then draw the image of the figure after a dilation with center A by a scale factor of 2. So the first thing you're going to do, I want you to go ahead and copy this on a piece of graph paper that you should have with your notes. If not, make sure you get that from me. And the first thing you're going to do is you're going to go ahead and draw a ray AB. This is the symbol for array right here. So when we say it in words, it's ray AB, but in geometric terms and geometric notation, ray AB is written in that way, where it has an arrow on one end and not on the other. And we want to extend it all the way to the edge of the grid. So what that's going to look like, just to give you an idea, I'm going to go ahead and draw one of these on my figure for you, so bear with me for a second. So ray AB will start at A, and it's going to go this way, and you have an arrow on one end. Okay? So that's how you would draw ray AB. The second thing you're going to do is use a ruler to locate point B prime on ray AB such that AB prime is twice as big as AB. Well, AB is only 1 unit long. I'm going to do one quick thing here. I'm going to make this a little thinner so it's not in our way. So there we go. Okay, so we have ray AB. We want to locate where B prime would be. So B prime is going to be twice as long as AB. So if AB is 1 unit long, AB prime will be 2 units long. So what we would want to do then is we want to go ahead and make a dot that's 2 units up right here. And we're going to call that unit right there B prime, right? Okay, that's not very clear, is it? Let me erase that a little bit. And I'm going to go ahead and change my pen to a thinner pen and see if that helps a little bit. B prime, that's better. Okay, so once we have B prime located, now AB prime is twice as long as AB. Okay, so the step 3 will be to repeat steps 1 and 2, only using side AC and AD. So we need to draw 2 more rays. And rather than draw those and take the time to do that, I have that in this box for you. So you're going to draw ray AC and ray AD. And then you're going to locate D prime where it's twice as long as AD, and locate C prime where it's twice as long as AC. Okay? Then what you're going to do is you're going to connect all of the primes. You're going to connect A to B prime to C prime, and C prime to D prime. And you'll get a figure that looks like this. All right, in the last example, if point A had coordinates 0, 0, then the table below will list the coordinates of the corresponding points in the original figure and its image. We're going to talk about that and what the relationship is. So here's a picture of what it looked like. If A was at 0, 0, B is at 0, 1, X is 0, Y is 1, B prime is at 0, 2, okay? So here's our image coordinate, 0, 2 for B prime. C is at point 2, 2. C prime is at 4, 4. D was at 2, 0, X is 2, Y is 0, D prime is at 4, 0. Well, what's the relationship between the originals and the image coordinates? And the cool thing is they're all multiplied by 2, which was the scale factor. So if we want to find the coordinates of the vertices of an image after a dilation, as long as we're centered at 0, 0, multiply the coordinates by the scale factor. Pretty cool, huh? So here's a chance for you to do that. Go ahead and graph triangle JKL that has these vertices. Then graph the image J prime, K prime, L prime after a dilation with a scale factor of 1/2. So here are our coordinates J, K, and L. if we multiply each of those by the scale factor of 1/2, we get each of the image's coordinates right here. So here's our original image, or excuse me, our original figure, and here are the coordinates of our image. Now if we plot all of those, here's what we get. JKL is in blue, that's our original. Our image is in green, notate, and you give those the notation using the primes. And I want you to get familiar with drawing each of these with the rays and locating each of the image points. And we can tell by looking at the original figure and the image that the image got smaller. That's because the scale factor was less than 1. If your scale factor is bigger than 1, the image is going to get bigger. So if the scale factor is smaller than 1, it's a reduction. If it's bigger than 1, it's an enlargement. So here's one for you to try. I'm not going to be able to do part B for you because I don't have enough room on here. So this one I want you to do on a separate sheet of graph paper because it's too big to fit here. So you will get a chance to try this one. So J, K, and L will look just like mine on your paper. The one that I'll do here is to go ahead and draw the scale factor of 1/3. So if my scale factor is 1/3, then what will be my coordinates of each of my points? Well, let's go ahead and do that. J prime will have coordinates. We're dividing by 3 or multiplying by 1/3, so we'll have 1, 8/3. K prime will have coordinates. 10 divided by 3, I'll just write it as 10/3. And the y coordinate will be 2. And L prime will have coordinates 8 divided by 3 and 2 divided by 3. So you can go ahead and plot those other 3 points. I've already plotted J, K, and L. Let's go ahead and plot J prime, K prime, L prime. I'll do it in a different color here. So 1 and then 8/3. That's really 2 and 2/3. So this one right here will be J prime. And I'm going to go ahead and change this again. This is a little too thick. So there's J prime. K prime is at 1, 2, 3 1/3, and then up 2. So that's about right here. A little to the left. Come on. It's not working out very well for me there. So we'll call that K prime. And then L prime is 2 2/3, 1, 2 2/3, and positive 2/3. So it's right about here. You can plot those points. And each of these, if I were to draw my rays, I should have drawn my rays on there first for you. Sorry about that. And let me put those in, let's see, we'll do those in green. That looks good. I'm going to make those thin. And we'll pick that one. Okay. That should do it. So if I draw my ray from the origin through J prime, J and J prime should intersect. And then from K, or from the origin through K, K prime should go through there. And the same thing for L and L prime. And I think I forgot to label that last one, didn't I? So I better go ahead and do that. This one needs to be in blue, right? So this one was L prime down here. Right there. So now if I connect those, each of those sides, and I need to do that in blue. Here is J prime to K prime and K prime. Whoops. Oh, and then I lost my, is it still in blue? No, it's not. Blue. Sorry about that. So K prime to L prime, and then back to J prime. Something like that. It should be quite a bit smaller. Okay, so this is the original, this is the image, and it is a reduction. And when you do letter B, it should be an enlargement. All right, finding and classifying scale factors. A dilation with a scale factor greater than 1 produces an enlargement. A dilation with a scale factor between 0 and 1 produces a reduction. We kind of talked about that. So here we have an example with a quadrilateral. The green one is the image, and it's a dilation of quadrilateral VZXW, which is in blue. Find the scale factor of the dilation and classify it as an enlargement or reduction. Well, you can tell by looking at it that it is an enlargement, so our scale factor should be bigger than 1. So what we need to do is just write the ratio of any two corresponding vertices. And so what we're going to do, we're using the y-coordinates of point V and V prime. So we're going to go ahead and look at point V right here, at its coordinates, and, excuse me, that was V prime, V and V prime, and we're going to compare those two. So if you take a look at V, it has coordinates -2, +2. V prime has coordinates -1, 2, 3, 4, -5, 1, 2, 3, 4, 5. So those are both right here, -2, 2, and -5, 5. So just compare the coordinates of one point. So if you take the y coordinates here and compare those, well, we're comparing 5 to 2. That gives us our scale factor. So since 5 over 2 is bigger than 1, it is an enlargement. All right, here's a triangle. It says triangle A prime, B prime, C prime is a dilation of ABC. Find the scale factor of the dilation and classify it as an enlargement or as a reduction. And the second one is an optometrist dilates a patient's pupils by a factor of 5 to 3. If the pupil before dilation has a diameter of 5 millimeters, find the new diameter after the pupil is dilated. So I want you to go ahead and do both of these examples and bring those answers to class. We'll see you next time.